So hopefully today I can introduce you to the world of volatiles and why they are such a fantastic biomarker potentially. So I left the question mark out because we currently don't know if they will become a biomarker of aging, but I'm very convinced. So let me introduce you a little bit to them. So they are a kind of subcategory of the metabolites. They are highly volatile. The origin can be either from your human tissue, your cells, but they can also be from the environment. Basically, what you breathe in is what you breathe out, or they can come from your microbiome. So they usually come in very low concentration, and that's also part of the problem. It's very difficult to measure them. Currently, we have roughly 1,500 of them that are known and have been identified. And just to give an example of like which are kind of the most known ones are alkanes, carbonyls, and alcohols. So people have worked on volatiles since quite a while, and they have been used to detect diseases. So here's an example where they used volatiles to detect COPD, but you can see that the accuracy of the testing is pretty low, but also this was a very early kind of like test that was developed in 2011. Further, they have tried it in Alzheimer's. Here, they used a couple more VOCs, and the accuracy improved. So 85% is not that bad. And then here in an example with a chronic kidney disease, you can reach an accuracy of 87% for early stages of the disease, or 100% if you're at a later stage. So the people have become better at it, at developing VOCs as a marker. And so I became interested because volatiles are non-invasive. You don't need a blood test, you don't need a tissue sample, nothing. You can just let people breathe into a little machine. And so what I did is we collected breath of 20 healthy volunteers, and they were from various ranges of age. And we did a very simple analysis just to kind of test the waters and see if we could predict chronological age. And using just 5 VOCs, we had a good correlation, good enough that we were convinced this is something that we have to like spend more time on. And happily at that time, Lynn brought her call out on the dynamic resilience, and we basically created a clinical study on falls. So we are looking at frail elderly people, 65 and older, and we are planning to collect 300 of them. And we are waiting for them to have a fall. So that's very unlucky for them, but it's great for us because it's a stress. And we will have a baseline measurement just with kind of healthy young people that will be used as a comparison. But then when they have a fall, we will see them again. We measure their VOCs again, and hopefully we can see how the VOCs change after the stress event. And then we wait, we give them some time to recover, and hopefully what we will see is that we have participants that recover very quickly or don't recover at all. And so all the things that we're trying to do is to find the people that are very resilient against the stressor, because hopefully that will give us clues about like what we can do to intervene and help them. And naturally, it's also a great predictor for people that are at risk of becoming more and more frail. And so you have an early time point of intervention, so you can give them drugs or diet or exercise. So we do a bunch of additional physical assessments and frailty assessments, and also give them questionnaires to have a very rounded picture of like what their frailty status is when they come in. So this is where we are currently. We have over 120 participants now. So this table was with 100 participants. You see that most of them are pretty fine. They are not very frail, but 7 of them already had a fall. And that was at the range that we predicted based on historical data that we have from Loughborough at kind of what percentages these falls are happening. So we are progressing nicely. So how are we doing all this VOC measurement? Let me do a little bit of introduction into like how it works. So we have an internal air control. As I said, there is a lot of things that you breathe in. So what we wanted to have is basically everyone breathes the same air to like minimize noise. And then we also take control samples from the room and also from like around the body, because a lot of like fragrances, shampoos, cosmetics, all of them are producing VOCs. And we want to know, is it coming basically from their like daily use? This is how it looks. This is a pattern of breathing. We're trying to capture the alveolar part of the breath. That's basically the air that comes out of the deep lung tissue, which is very, very rich in VOCs. Then we run them on a mass spec, and we are having additionally 54 standards to keep the measurements really, really exact and know that there is no shift. And then what we get is this kind of like peak pattern that you might have seen in other studies. And usually what is happening is that a postdoc sits there and identifies every peak, which will take forever. And we think that like human life is too precious to waste. So we are developing an AI to substitute our students and postdocs. And this is how the AI currently works. So the AI goes over basically the picture of the measurement, and line by line, it goes through the system and identifies the VOC pattern of like one compound. And then it makes the decisions, yes, this fits, or no, I have to go through that system again. And hopefully kind of like comes out with a list of compounds. So currently we can detect 160 of them. We have reduced the time. The analysis takes from 90 minutes to 1 minute. And the next step is that we try to quantify the signal. So we're capturing all of the compounds that we're measuring. We already, as I said in the beginning, we have 1,500 known compounds. We already have now in our library 1,000 of these compounds, and the list is kind of like growing. And in parallel, what we're doing is that we are also looking at cells. So we're looking at aged models, tissue models, to mechanistically understand which of the VOC parts are coming actually from cells, and are there some clues of like interventions. So we do find VOCs from the environment, from your microbiome. This is where we are currently. So hopefully I have introduced you to the fascinating world of breath analysis. We have established a pipeline of automatic VOC recognition with 160 compounds, with a list growing. We have reduced the time for analysis, and we found some interesting overlap between breath and cell VOCs. So we seem to be on the right path, and we have now created a library of 1,000 VOC. So please, hopefully next year, we will be able to show you more of this, because as Lynn said, we're 1 year in. So hopefully in 2 years' time, we will have a signature that will tell us who is resilient and who is not. Thank you very much.